So in front of you is 2 HPUs, which are hydrogen power units. We're currently powering between 30 and 50% of the site load. Yeah. So we make our own green hydrogen in the UK. We use fuel cell power to create electricity. The byproducts are deionised water and heat. So we have 3-phase off-grid power, basically anywhere and everywhere. So this is the Meg C, which is a multi-element gas container. This is a 30 foot, so it's got around 400 to 440 kilograms of green hydrogen in, so you've got 2 of them. So just under 900 kilograms of hydrogen. We do a 40 foot and a 20 foot, so you can get anything up to 660 kg in a 40 foot. We take that hydrogen through the purple hoses you can see, goes into the gas panel on the back. That gets regulated from 300 bar down to 8 bar, which then makes it accessible for the fuel cell, which then the fuel cell then splits the hydrogen. You reintroduce oxygen into the fuel cell, which reoxidises the hydrogen, and it gives you a potential difference, which is a DC load. We then take that DC load, put it through inverters, which changes it from DC to AC, and it makes it malleable for 3-phase power. We also have battery storage underneath the unit, which is what the output is the DC batteries, and the fuel cells used to recharge the batteries. So these containers, if they're full, how long could it power the site for? So these 2 will do the full job. So from start to finish. So we actually start. We've been here near enough 2 weeks now. Yeah. So there was obviously a low load for the first week when testing and stuff was going on, but now that the site's fully up and running, we'll do the full thing. 30 foots and 40 foots, depending on site load, can last anywhere from 2-3 days to 1 month, 2 months, depending on what they're charging. Yeah. So 7 kilowatt chargers. Say if we were hooked up to 10 of them. You could be looking at 3 weeks, 4 weeks before you get a gas swap. So we're not in and out constantly. So if you could imagine, so looking at the 20-foot shipping container, where the stainless grill is on the far side, the batteries are probably just underneath that. Okay. So the full subsection of the floor is batteries, and then there's a floor frame which we then put floor tiles on. So there's 240 batteries in there, which are 250 kilowatt per unit, so you've got 500 kilowatt of battery storage there. So essentially the output comes from the batteries, which is why. So we use 2 UPS systems in each unit, which is just instantaneous power. So any load spikes, load drops. The fuel cell obviously recharges the batteries. If we were to lose a fuel cell, or for some reason we ran out of gas, you've got that 250 kilowatt hour of battery storage. Yeah. To either get an engineer here for a fix, or to swap the gas out, or just get the fuel cell back up and running.
So Menter Mon, we've been involved in renewable energy for about 12 years. So we are developing the Model Ice tidal energy project off Holyhead. So that's progressing well. And about 5 years ago, we started looking at hydrogen, green hydrogen. So we have been progressing the Holyhead Hydrogen Hub. So we have planning, we have land there, and the plan is to use power from Model Ice to produce the power to produce green hydrogen. Yeah. So it just adds value and keeps that value locally. Yeah. So this week at the Eisteddfod, you talk about stuff a lot, but it's actually having it here to people to see it and taste the water. So the young people here, the politicians here, the other stakeholders, so they can see it's real and how it can be used.
So this is the byproduct?
But yeah, so the byproduct is just deionised water, so it's essentially just H2O that was hydrogen 30 seconds prior, which has just been reintroduced with oxygen. And so there's no minerals.
Both of them do the same thing?
Both of them do exactly the same. So we're actually sort of containing the one on the far unit. Yeah, so we can get, we've got cups and stuff. So the nitrogen that we've got here, which you can see going into the gas panel, so essentially we use nitrogen actuated valves. Yeah. So inside the gas cabinet, we can't allow, if there was a H2 leak, you want to minimise the chance of there being a spark, which would then cause an explosion. Yeah, so the reason that we use ISCY, which is like intrinsically safe cable, it's 0 volt, and nitrogen. So essentially when we switch lines over, nitrogen will fire through, switch the actuator from open to closed or closed to open, and that allows hydrogen to then feed through either line A or line B, which is the input from the Meg Cs, and then also all the valves after that to get to the fuel cell. You can have a cup of tea, you can have a cup of coffee, you can You can do everything you can with normal water. You could shower in it. You could whatever.
So much water.
Yeah, there is. With it being humid as well. Yeah. So when the site load increases and when it's humid, it obviously creates a lot more water. To be honest, the load they're doing maybe half each. If they were doing 75-80% each, you wouldn't see as much water coming out of this, as most of it would get turned to steam. It'd be coming out the top of the vents now. Yeah, so the hotter it is, the more chance it is of coming out with steam, and less to come out of the overflow.
Or you could still capture that.
Or you can, so you can capture it for.
It could become another power source.
Yeah, so we capture it for. You could do radiators, stuff like that, CHPs. So people use them for cleaning, even toilet water at festivals or sets. Yeah. So these are power locks that are basically coming from your batteries through a load panel, and then you've got 3-phase power, and then this is the earth, which goes to the earth array, where we've got like 2 to 3 earth rods, like 2 meters in the ground. So these dry air cooler. So we've got 2 coolant loops. We've got a primary coolant loop and a secondary coolant loop. Yeah. This is hooked up to the secondary coolant loop, which is Thermox. Just helps keep the unit. So which is a good thing, because we'd rather the heat coming out of that than being obviously inside the unit.
And this is the job.
Yes. The primary coolant loop, which you don't get to see on the outside, that's purely for the fuel cell. So the coolant that we use for the fuel cell is non-conductive. So obviously, if people have computers and stuff you could have non-conductive liquids. Yes. So they've got the fans running and stuff like that. So we could essentially pour a whole lot of coolant on the batteries, and it wouldn't cause an issue because it's fully non-conductive.
And the heat that's coming off you, is this a heat that you could use? So you're like
you could use
it to like funnel it into an event space.
Yeah, so heaters or offices or cabins and stuff like that. So there is ways. So there's ways and means of getting both the deionised water and the heat to capture that.
Yeah, and because the Eisteddfod is a perfect example, because it goes from place to place. Yeah. Rarely has grid. It does here. Yeah. But the Eisteddfod, you have other festivals. Wales is a popular filming location, so it's ideal for that. You've got a nuclear power station being built down the road. Ideally that could be powered through HPUs and not diesel generators. Yeah. And it's just keeping that, from our perspective, keeping the money circling in the economy.
And that's a really good point, because it's the skills, it's the employability, it's training up, it's bringing prosperity then and secure jobs to North Wales,
Yeah, because for us, energy is more of a regeneration tool, because the energy is almost a byproduct.
Yes.
Yeah, because we're about, skills, employment, supply chain, ambition. Yeah. And really energy is a way of doing that, really. Yeah, because in Anglesey, the average population age is now 47.
The average.
Yeah, and in Wales it's 42. So people are leaving Anglesey because of lack of opportunities. Yeah. So that's another reason, to keep people.
Yeah. It's back where the magic happens, and then the magic. Right. So this is a fuel cell. So this box here essentially is where we split the hydrogen atom. It takes your proton and electron, fires around 2 separate circuits. You reintroduce oxygen, which reoxidizes the hydrogen, which is where you get your deionised water and heat from. The potential difference which this provides is your DC load, which we then take through these cables. We then put it from the inverters through the transformers, which help reduce noise, and then it meets up with the UPS system and the batteries where we get our output. So that's constantly charged. Whilst this is running, it's constantly charging. This is doing it. So you've got the brains. So that's the brains, which you can see. So I can go through a few screens. Yeah. We've got like gas pressures, nitrogen pressures. We've got what the fuel cell's doing, the power input, power output, thermals, heat, what we're emitting, what we're saving. Yeah, they're nice. Info, so we've got like loads, what the fuel cell's doing, stuff like that, and then we've got like commissioning where
it dropped out to like overnight.
So that was recently. So that would have been. So if you see this green line, there was a load drop off. So when the load drops off, to prevent backfeed, the inverters will essentially switch off and then come back on again. So it's just a protection protocol really to stop backfeed, and then we can just change. We can run different pumps, different fans, change how we're running the unit itself, turn UPSs off, turn them back on. introduced grid ornamentation, so we can run on grid, off grid. Yeah, so that's basically it on the screen side. Yeah, this is the balance of plant. So you got your compressor at the top. Runs up to 11,000 RPM, this is what's forcing oxygen into the fuel cell. You've got your cooling unit in here, and this is part of the primary and secondary coolant loop with the heat exchanger. So you've got both coolant loops going through that at the same time. So the inverters essentially, so they're taking power from DC power from the fuel cell and switching it to AC, and then with them putting it through the transformers, and then we introduce that with the batteries under the floor. This 30-45 seconds ago was purely hydrogen.
So the first minute there, drink.
Quite warm.
Yeah, it will be. It'll be about 45 degrees, I reckon.
So here's a question to yourself then. What are you hoping? Next steps, the future. What would you love to sort of happen next from, you're exhibiting it, it's showing it, the investment happening?
Well, as I said, we've got the land, we've got the planning.
Yeah.
We've got a grant application in at the moment for funding. We're partnering with EDF from France. So we're looking at a 50-50 partnership with EDF at Menter Mon. So that's interesting. You've got a big global energy company and a small social enterprise. But you need that, that capital injection. Hopefully we're going to be partnering with Urdd in terms of being an off-taker. So if everything goes well, we should be starting the build of next year in 27. Whether we'll have tidal energy from the start, I'm not sure, but that would be the ultimate.
It all knitting together.
Yeah, but also what you've got in in the area, because ideally you want a local market as well. So you could have your data centres potentially.
I'm guessing like big vehicles, like lorries, etc. Getting that sort of
and the port as well. So there's you could look at ethanol and methanol and ammonia. You can use that as well. You can produce that as well, and that could be used in the port. You often hear people bang on and say, "Oh, it's not always windy, not always sunny," but you can store it in a battery or hydrogen.
Very busy, yeah. It's constant. It calms down in the winter a little bit. It used to. It definitely. But yeah, we're ramping up. Especially as we make more units, there's more customers. So there's between 50 and 80 units of these ones at the moment, and then we've now moved on to HPU2, which is essentially it's 5 of them fuel cells. So it's a smaller unit, 5 fuel cells, 500 kilowatt of continuous power. So I think we've made about 5 or 10 of them, and then that's just they're in now mass production. They're like basically in mass production now. So we probably won't see many more of these ones getting built, just upgraded and maintained. And then, because customers and we would prefer to give 5 fuel cells out than the one. So the process to make it like an agile version as well, so one that can be towed on the back of one of the vans that we've got, or a van or pickup, something like that. So then that could be a 100 kilowatt fuel cell, pulls up and just gives power within an hour or two. So whereas with these you need your big heavy goods vehicles and stuff, and the planning and stuff, whereas we could just hook one to the back of one of the vans, take it to an off-grid location, park it up in a field, and it's ready to go.
Should be by the end of 2028.
I'm going to be coming up to Anglesey. Yes, it's amazing.
Yeah.
You're going to be dancing around.
But before then, you can come and see Model Ice, tidal energy.
Thank you.
Yeah. Okay.
No worries. Thank you.
Really excited for this one. We're going to go see the hydrogen plant on the Urdd Eisteddfod site. It's going to be really cool because it gives access to clean energy for the Urdd Eisteddfod, and on the Vanti compound we've got our batteries and our HVO fueled generator as well. So it's all about lowering emissions on site. Hopefully it'll achieve long-term affordability with hydrogen energy being used. As you've sort of just heard, there's multiple ways that we get power. We get solar powered grid power as well coming through on the site. So there's 3 sources. We've got hydrogen, battery and solar power as well, and then HVO fuel as well for our generator. So 4 pieces of different types of energy that we're getting on site. We're there as well to try and reduce environmental inequalities for people and tackling pollution and local pollution by bringing events like this, which have a very low impact on site. And we're investing in the future of the future generations as well by things like the Urdd Eisteddfod, bringing culture and Welsh language to the people of Wales, and hopefully opening doors. There's a Learners' Day now as well, which is great. And again, making large public events more sustainable for everybody. You saw me with Emlyn Davis, and if not, look at the waste and recycling one. Nothing goes to landfill. There is 6 different waste streams, only one of them is the general waste, which goes back to energy recovery systems, but it is picked through twice before it actually goes to that point. And then having these new hydrogen-based sort of companies coming around, it creates skills, jobs and opportunities in Wales. So this one project is tackling so many different things to make Wales a more equal place for us all to live in. So let's go and have a look and get a tour.